Okay, so what we've got here is a basic retort stand. It's got a large mass on this side and light mass on this side. Now we want to find the center of mass. Now one of the quick ways that we can do it is basically just moving our hands into the center. Now what happens is I can move this hand really easy because there's less force acting on this side. Although on this side I've got a lot of force acting downwards, so it's very difficult to move these fingers. So what I'll try and do is try and move both of my hands together and as quickly as possible, and the result is what will happen is I will find the center of mass simply by moving my fingers together. Let's try again. So if I move it nice and quickly, nice and stationary, just move the two things together and there's the center of mass. Now what's happening at this point, and if I just manage to get it on my finger, so what's happening now is the torque on this side, the force times the distance, is basically going to equal the force at this end with a huge distance. So basically what we've got is a torque on this side equaling the torque on this side. The center of mass is acting at this point in the center. So we can very quickly, simply by taking our two fingers on the object, this will allow my finger to move because there's little force acting in this direction. So I can move this together until eventually both fingers, and there's my center of mass. And you can see it's nice and straight. So literally what this is showing is the example that I put in the post, where basically we had the same torque acting on this side as this side. They're in equilibrium, but the force here is counteracted by the small distance, whereas the small force here is counteracted by the large distance on this side. Okay, so I hope that makes sense.